Well, hello everybody. So today is my first time in the DjangoCon. Yeah. So this talk is about Neo4j with Django and neomodel library. So let's start. So it's easy to come across with use cases where it could be useful to use graph database, and we don't realize since we are used to other types of database. The idea of this talk is to present some examples of when to make sense to use it and incorporate it with our Django backend using neomodel library. So first of all, I'm going to talk about me. My name is Dara Silvera. I'm a full stack developer at Octobot, which is a software company with 9 years of experience. I'm from Montevideo, Uruguay. It's a small country in South America between Brazil and Argentina. I'm a huge fan of Formula One. I love rabbits, traveling. Oh, yes, we have fun of Formula One here. And I'm kind of a makeup artist. And this is my QR of LinkedIn if you want to connect. We have SQL database and NoSQL database listed here. When you have a problem, your mind is just trying to go to a relational database. Even though they are called relational, they don't handle relationships very well. For NoSQL, we have four NoSQL database listed here. 3 of them are don't have the concept of relationship, but each one is created to resolve a particular problem. Then we have the graph database, and then we have Neo4j. This captures the relationship as part of the data. Sorry for that. Okay, so Neo4j as an empty graph database. The connections are already there, stored right in the database. Native technologies tends to perform faster, scale bigger, and run more efficiently, calling for a much lower hardware requirements. This capability to traverse data without the index lookup make it more efficient. So what does this look like? The data model for Neo4j is something called property graph. Apart from defining the nodes that in this case are person and car, we have to define some attributes that either define them. These attributes can be a string, a Boolean, or a numeric. For relationships, we have to define exactly one type, one property. That in this case we have loves and owns, for example, and we can have 0 or more properties, like for example the model of the car. Signs and the date of when it drives. Okay, so when to use graph database? First of all, some complex data relationships. Some databases have relationships that are complex by their very nature. An example of this is the Paradise paper. It was an investigative journalism effort that exposed people who were using offshore financial instruments and accounts to hide different companies. So the people who were using this mechanism were trying to hide their wealth. Another example could be highly connected data where the grade of connectedness is very large. Hierarchical data when, for example, we have a self-foreign key, and it could be difficult if we try to do a lot of joins. Then involving schema if our data structures is not well defined yet, and we may suffer some changes in the future. Graph database, it's quite interesting for that because it's not so fixed. And then real-time insights. An example of this could be a recommendation system or prevention fraud payments. About complex data relationships, I'm going to bring an example of this later. And for hierarchical data, I bring a small example. So one powerful feature of Neo4j is the ability to query for paths of arbitrary length. This allows us to find a connection between nodes that we don't know that they were there, or even without knowing the length of these connections. So for example, if we have this database, then the labels are employee and the relationships are managed, and we wanted to know all the people that Shane managed, we can know this with this simple query without adding the maximum length of the path. So the result of the query, it will be the same graph as here, but if we put, for example, a 3, it will be from Shane to Jason because it will be 3 relationships between them. There are a lot of graph algorithms that we can use in Neo4j. I just bring 3. The first one is centrality, that is used to determine the importance of distinct nodes in a network. Then we have community detection that are used to evaluate how groups of nodes are clustered or partitioned. Then we have path finding. They could be find the path between 2 or more nodes, or evaluate if a path exists. And of course, we can use more of one of these algorithms together, so that's kind of interesting and give us more insights about our database. So let's talk about Cypher. Cypher is a high-level query language based on pattern matching. It's used to create nodes, update, and delete information and query graph. So, for example, for nodes, we have the variable between parentheses, and then we have to define the labels to identify them. And optionally, we can add the properties. And then for edges, the edge has to be between brackets, in this example, and between 2 nodes. For example, here is in between N and B, and we have to, of course, add the direction between these nodes. And optionally, we can add the properties to identify this relationship too. So there are a lot of clauses in Cypher, but I bring some examples of them. For example, match is to specify the pattern to search for in the database. The clauses where is to add contrast to the patterns. Otherwise is to specify that the output should be sorted, could be ascending or descending. Return defines what to include in the query result, and limit is to constrain the number of rows in the output. So it's readable, and I think that if you read it, you can understand the query. I think that's fantastic. And here it's a small example that we want to know all the people that Dan loves. So in this example, this is a variable that can be, for example, he can love cars or whatever the labels can be in this graph, and we will return all the labels that he loves. Well, so let's talk about neomodel. What if we like our existing stack, but still want to benefit of a graph database? Neomodel is an object graph mapper for Neo4j graph database. It's familiar with Django model style definitions. So here is the shape of the data of Parada's paper. So first we have the entity that is the offshore legal entity. This could be a company or a trust that was created in a low-task jurisdiction. Then we have an officer, that's a person or a company who plays a role in an offshore entity, such a beneficiary or a shareholder. And then we have the intermediary, that is a go between an offshore corporation and an offshore, an offshore corporation and a person that wants it. And then we have address that are all the address that was found in the ICIG database. And others are other entities that plays a role in this database. So these are all the possible relationships, but these I only use a pair of them. So for example, for entity, we have like the relationships that this can be defined using relationship from, relationship to, or relationships. So as I said before, it's quite similar to how we work in Python. I mean, nodes are defined in the same way, classes are defined in Python, with the only difference that we must define as neomodel property objects. And we have to also define which is going to be the ID. In this example is node ID, and we just write unique ID property. And this is the same but for officer. So if we see here, for entities, we have a relationship to, and this is the name of the relationship. Here we import the model. So we are an officer, we have entities and relationship to. But if we go back from to entity, we have officer that has a relationship from, and it's the same name of relationship. So here we have from officer to entity the relationship. From entity, and of course for every model, we have to serialize the connections. And this is how we serialize them, the relationships. And this is how the database looks like. This is a query made with Cypher. For example, if we want to discover the shortest path between two officers, this is how can we do it. Here we have the name that contains Ross Jr. This is the node, and the other one is contains grant. You have to believe me, this contains grants. And this is how we use all shortest paths, and this will give you all the shortest paths navigating with these relationships, and maximum length of 10. And then we return it. So it's quite interesting how we can visualize the data. And neomodel contains an API for querying set of nodes without having to write Cypher. So for example, we have filter, the filter method borrows the same Django filter format. For example, less than, greater than. Then we have get as the same as Django, has, that is to know if a node has a relationship or not. Order by the query. And then if we want to query a more complex filter, we can import Q from neomodel. And this could be an example of that, how to use it. And if we want to still use Cypher, we can. We have to import DB from neomodel, and we have to write the query. This is almost the same query between if we're doing with the APR or we are doing with Cypher. And this is a more complex query that's the same that I showed you before. I bring just a part of the result. And a thing that's about neomodel is that the query doesn't bring us all the nodes that are between these two nodes. Just bring us the first, the start node. So in this case is Ross Jr. and then the end of the node, that in this case is Blomberg Anthony Grant. And the size is the size between this path. So in this example is 6. So I think that it's a work in progress traversing data, traversing the graph with neomodel. And a conclusion, well, there are a lot of conclusions. First of all, graph database are the best way to explore the relationships between entities. It's much more intuitive to use this for this purpose than SQL database. And a person that was working with the Paradas papers say that if we were looking at the documents and we will never find out all these complex relationships. So Neo4j helped for that. And of course, the data visualization, I think that's great, and that you can see how your query is visualized. Of course, different insights, as I said before, if we use this, if we use centrality, or if we use pathfinding, or all of that, it can give us more powerful insights of our graph database. So I think that's all. I have to say thank you for hearing me and being today here. So, and the questions will be addressed in the hallway. So, thanks.